physical quantities and units. तो शुरू करने से पहले we must know one thing कि measurement होती क्या है? What is a measurement? So we can say एक example लें 2 kg, 4 meter, 10 degrees centigrade. So we can see a common thing that a measurement is always a combination of number and unit. Fair enough? Now, if going further, then we have to define what is a physical quantity. So physical quantity is defined as anything that can be measured and represented by in terms of magnitude with its unit. So we can say that anything in our environment that is measurable, that is called a physical quantity. For example, you can measure mass of an object, let's say 2 kg. You can measure the length of an object. You can measure a temperature. So these are all basically physical quantities. So keeping this in mind, basically physical quantity has two categories. Number one are called base physical quantities. So in base physical quantities, there are 7 base physical quantities. Number one is mass. The unit of mass is kilograms and are represented by kg. Likewise, then it's length represented by meter, time represented by second, then length, mass, length, time. You can number 4, temperature, that is measured in kelvins, intensity of light, that is measured in candela, amount of substance, that is measured in moles, and the last one, the amount of current, that is measured in amperes. So any physical quantity in this world is basically combination of any of these 7 base physical quantities. So now when we're saying that any physical quantity is a combination of physical quantities, then we can say that basically there are derived physical quantities. So derived physical quantities are basically a combination of base physical quantities. We can take an example of, let's say, area. Let's say, starting from area. Area is basically length times width. So length is also a length measured in meters, and width is also measured in meters. So it is in meter square. We can take an example of, let's say, pressure. The formula of pressure is force per unit area. So the SI unit to measure the force is newtons, and to measure area is meter square. So if someone asks me to convert them into base physical quantity, so we know that kilogram is Newton is kilogram meter per second square over meter square. So if I want to write in a standard form, I can write it's 2. We can take an example. Let's say number one is area. We can take an example of, let's say, current. So basically, current is the flow of charges in unit time. I is equal to Q by T. So Q charge is measured in coulombs and time in seconds. But if I want to convert them into base physical quantity, I can write I is equal to Q by T and Q is equal to I into T. So basically coulomb is basically equal to ampere second. So I can write ampere second over second. So current has a unit of ampere. So I hope you got the point. Moving further, you must know what are scalar quantities and what are vector quantities. So basically, a scalar is any physical quantity having only the magnitude. And vector is a physical quantity which is combination of magnitude and direction. So we can take example. Let's say energy. When we say energy, it is in joules. So energy has no direction. It just has a magnitude in joules. When we can take example of, let's say, speed. Speed is distance over time. So we speed is has no direction. So if we give speed some direction, if we give speed any direction, then it is called as velocity. So velocity is basically displacement over time. So displacement is a vector quantity. You always cover displacement in some direction. So velocity is a vector quantity time. Now, moving on, you must know prefixes. What are prefixes? Whenever a physical quantity has a huge amount or a very less amount, we use prefixes. For example, if someone says, I have 500,000 kilograms of sugar. So we have to convert this form first into tens power, like 500 times 10 raised power 3 kg. Or I can write 500 kilo kg. It is a very layman example. We can write more, let's say in case of resistor or capacitor, let's say capacitor. He says that I have a capacitor of 1000 microfarad. So micro is basically 10 raised power minus 6. So I can write 1000 into 10 raised power minus 6 farad. So I can convert it 10 raised power 3 times 10 raised power minus 6 farad. Or simply I can write 10 raised power minus 3 farad. Or I can say that I have a 1 millifarad. So 1 millifarad and 10,000 microfarad is the equivalent quantity. So I'm writing to, you can have a table in your book, or I can write over here. Let's say deci. Deci is basically 10 raised power minus 1. Centi is basically 10 raised power minus 2. Milli is 10 raised power minus 3. I have micro, that is 10 raised power minus 6. Then I have nano, 10 raised power minus 9. I have pico, that is P 10 raised power minus 12. Likewise, I can write over kilo, K 10 raised power 3. I can write mega, that is M 10 raised power 6. I can write giga, G 10 raised power 9. Okay, so these are the prefixes, and that is the equivalent and its power quantity. You are in the paper. He can ask you to convert any form to another form. Like I gave the example previously of the capacitor. Now, moving further in this topic, you must know what is a homogeneous equation. So, whenever say we say homogeneous equation, you must know that homogeneous equation is an equation in which we have the same base units on both sides of the equation. Let's say I take an example of first equation in motion, that is v is equal to u plus at. So velocity is measured in meter per second and u is measured in meter per second. Likewise, it is meter per second squared into second. So you can see over here, we have same base units on any other either side of the equation. So it is a homogeneous equation. I can take any other example. Let's say I can take third equation of motion, that is 2as is equal to final velocity square minus initial velocity square. So uh, you can say the acceleration is in meters per second square into meter. If I put meter per second and whole square, it will meter square per second square minus meter square per second square. So in the end, I have same base units on either side of the equation. So it is a homogeneous equation. I hope you got the point. Next, in the video, I will explain about errors and uncertainty. Till then, goodbye.